All right, so our next speaker is from Lablicate. It's all about OpenChrom.
Yeah, thanks a lot for having me. And I thought, as I'm at a talk about ontologies, so let's start with one. I look everything up in Wikidata. So let's go, let's say, what is OpenChrom? And let's make this look a little nicer. Okay, thanks. Let's make this view. So what I'm after all, OpenChrom is a chromatography software. Well, you could have known, and it's also an open source software, which is also probably a novelty. At least that was the reason for its creation, because there was none at the point. And now you want to probably guess, yeah, well, who's doing it? Who is the developer of OpenChrom? So let's have a look. And it's an entity called Lablicate, and let's see what is Lablicate then, because I think this is also important. It's a software company. And it's a business, because I think the prejudice with open source usually is it's something in academia. A PhD student is doing it, and after 3 years he abandons the project and everything is gone. And this is not the case in this particularity. Lablicate is a company that's been there for over 10 years, so it's well above the startup phase, and it aims for long-term business solutions for their customers. And yeah, the main product is still OpenChrom. And why is this relevant in this particular constellation? Why was I invited here? So let's say the writable file format is the Allotrope data format. And I put this in reverse because we want to find out, OpenChrom can write the Allotrope data format. So we are in a different position of the chain here of data science. We are not dependent on it. We don't need to have it to function, but we can produce it, which might be interesting for some, at least I hope so. So let's dive right in. What is OpenChrom? When you start OpenChrom for the first time, it doesn't look like this, sorry. There's a welcome screen, of course. So it looks like this when you start it. You can actually download it, openchrom.net, start playing with it, click the demo button to see some data if you don't have something at hand. But what you will be asked at first is this dialog will appear, and it will ask you which instruments do you have, which vendors, and it's file-based, so it reads the files. And here's also already an exception. These data converters are not open source. Out of courtesy for the vendors, we won't share how their proprietary formats are created. So this is a secret, so to speak. And if we scroll down, we have, of course, we have ABSykes here, we have Agilent here. I mean, Agilent, you can use their official exporters, so actually no need for Agilent data here, but actually this started with Agilent instruments. Actually, it started with instruments when Agilent was still part of Hewlett-Packard, so it goes back to that. And we have Allotrope in here, so it's just another file format, basically. You can get ADF and ASM. Actually, I know everybody loves ASM, but we also love ADF, so that's it. But we have many more. We have Bruker in here, Karma, many smaller ones. We have some niche products. Maybe also you see some companies that don't exist anymore. We can still read their data if somebody needs it, so no problem there. And of course, shout out to the guys from Shimadzu. We can also read a lot of their instrument data. And also, thanks for Thermo for hosting. We can, I mean, you are very laborious at creating various file formats. So we had, it was quite a lot of work, but yeah, thanks for it. Also, Waters, we can read a lot of the data. So just, I urge you to just try it out, and if something doesn't work, just contact us and maybe we can get it to work. So we selected our data. So how does this now integrate into the workflow of the OpenChrom user? So we usually open our, you can also see OCB, it's also our own open file format, but it's our own file format, so we are also guilty of the vendor file format problem. So we have that. What the user usually does, I mean, you see the raw data, but you don't see any results. So what we do, let's go for peak detection. Let's choose first derivative. It's the simplest one. It's also open source. Just takes the peak maxima. And now we see lots of peak indicators, but I can't, it's too much. So maybe at first we go for peak integration. This might be strange for people who are used to chromatography software. For us, peak detection, like the peak shape and the integration, the area is 2 steps. This might be counterintuitive, I'm sorry for that, but we won't change it because everything is a plugin in OpenChrom. But what we can do now, we can now filter the peaks. And I choose high pass peaks, and I type in 50 number highest peaks, so we only take the largest peaks, so it's already a bit cleaned up. And I can bear with that. I'm only interested in the major components in here. So now I think the steps that I enjoy the most, peak identification. I choose the NIST one. We re-implemented the NIST MS Search inside OpenChrom. I'm not running another application in the background. This is because we had help from the nice guys at Mailänder. And what you can see, I just click the button there, we cite our sources. So shout out to Stephen Stein and Donald Scott, who not only just published a lot about the algorithms, but who also were a major help. So we could do this, so let's run it. And we could also speed it up a bit because we are not a 16-bit Windows 32 application anymore. This is now running on a multi-core system, so it's pretty fast. And now we get our results tables. We get match factors, CIS numbers, names for, and now we can actually work with that. We have a result. And now that we're happy with it, we can save it. And we can also now, since this quarter, we can save it as ASM, JSON, and we can also save it as ADF. Actually, we like ADF a lot because yeah, these files tend to be quite big, so let's just save it. Let's do ADF. You can see the write speed. We managed to negotiate a data cube with Allotrope that writes quite fast, and it's also not so super large. You can see it's 50 megabytes. And you always have to keep in mind that, oops, by default, let me go to the export folder. And I can look in here, and it saved the original file inside as a data package, which I think is a really cool feature, and which we integrated here. So you can see also ADF is a first-class citizen in OpenChrom. It behaves like any other file, and I can also show it to you with some other real-life data. Let's take something from the HPLC DAD world. Also, huge thanks to Heiko from Agilent for sharing some data so we can work on make sure that we're interoperable. And let me close that one. So we can see ADF imports also with metadata. We can see it already has peaks integrated in here. And what we can also do, we can look at the original ChemStation data and maybe open that up. And we can see in the bottom, you can see the wavelengths, spectrum. And while I click here, click on the peak, see what's going on there. So we have everything at hand. But I mean, that's not all about ADF. ADF is so much more. So we dedicated its own perspective, we call it, to it. So what it does, it actually shows everything that ADF has. This is an example from Allotrope. It doesn't have a data package, but if it had, we could delete files, we could add some, we could export them, like if we want to look at them in another software. And we can see the triple store. So this is a nice thing. So we can like search for AFR. Let's search for all results. I'm a results guy, and we see a lot of things here. Let's pick one. We have lots of peaks in here. We can look at them and kind of traverse this tree. This is really usable. I used this a lot. Also, this perspective is also, it started out as a debugging development tool that we used to get used to with the format, but it evolved to something that I think users might also like because it also has a nice visualization. For example, the data model graph. Let me lay out that one, make it full screen. And now we can traverse the graph because, I mean, it has nodes, it has connections, and I know at first this might be overwhelming, so especially in larger files when there are multiple chromatograms in it. But again, here you can also search, like, I mean, it's chromatography, maybe search for chrom something, and then, we found the chromatogram data cube. We found the gas chromatography aggregate document, which is pretty much on top of the hierarchy. And we can navigate in here and explore this. So if somebody is really new to this, or yeah, this also might be a great help. Also, if you have no idea what the chromatography column document is, you can actually get a tooltip here, or you just double click it, and the not so fast Perl server from Allotrope will answer, but it will answer in time. We will look at this later. And actually, I want to show you also the 2D data, which is always, look at the cool Edgeland. These files are really help development a lot. So again, huge shout out. You can also look at 2D data, and we can also, this is the data range, like the bar on the right that you see. I can change this a bit to make it sharper and to adjust the image a bit. So this is just exploring the data. And this is also a pretty naive editor. Even if we don't support like the technique, it's not yet in OpenChrom, you can still read it with this generic editor because it will just get the dimension and the, in this case, two-dimensional data, but it can also plot like the measure. Let's take another one, like plot measure with this dimension. So this works with almost any data. Also legacy data, I found data that predates the standards actually. We can still open them with this editor and look at them even though they don't comply with anything. So yeah, you might say, yeah, I don't have just one chromatogram. I have like a lot, and this seems a bit tedious. Also, this right-click menu is probably a little large. So yeah, what do we do? Well, let's batch process this. Let's go here. We have a wizard for that. I also have a product here that has a nice name. And let's call this, this batch job. And let's do MS data. And let's throw in some data in here. And this is a funny data file I found online. Somebody injected some perfumes, probably from their girlfriend, into a GCMS and uploaded it to Zenodo, which is a content platform where you can share data. It's not moderated, but I mean, it's super cool. So let's do the same thing. Let's do a peak detector. This time we do something else. MCAR-AR, and if you don't know what this stands for, yeah, we also cite sources in here. This is not this is a deconvolution algorithm that can detect overlapping peeps. So this is a proprietary add-on, and my colleague Lawrence did this. So it's one of my favorite plugins. It's really great, and he also published a paper on what he did and what describes it. So let's do the same thing again. We do the peak integrator and we do the trapezoid integrator, the area. Sometimes when you do quantitation, sometimes the peak height is more stable, so you can choose there. Or if you have other ideas how the peaks should be integrated, we could just add that. It's super modular. So again, we say not all peaks, please. We only want the major components. We only want to have some fun with that. And I go specific options. Again, 50 is, I think, a good idea for those as well. And now you're all pretty patient, but I'm an impatient person, so let's do something else now. Let's do PBM, whatever PBM is. And it's let's also open up that one. this is I'm looking at ChemStation data right now, so I thought, yeah, maybe let's do the original ChemStation identification method that we got working now. It needs an Agilent database, so it's a bit tied to a vendor here, but also again, huge thanks to Agilent for making this possible. So we could, I mean, if we look at this is Fred McLafferty in the 1970s publishing the algorithm of matching mass spectra. So this is really going back. We preserved this, and the funny thing is, if you run an algorithm that is developed in the 70s and optimized for the hardware constraints they had, and I run this on a laptop with 16 threads, let's see what happens. And so this is also a nice thing also for compatibility. If you developed something with ChemStation, you don't want to re-evaluate it. This is the original implementation with all its quirks, and but it's great. And of course, now the most important step, we do something proper here. We export it, and now let's go for ASM, because I know you want. And so let's make science reproducible again, and it doesn't have to be that hard. So, okay, I configured this. I'm happy now. I'm going to go for execute, and we also have steps that you can do a peak review where you have a manual integration, or somebody presses a button and says, this peak looks good. I have skipped this now because we don't have all the time in the world. So, but we're already done, so nice. Let's look at this. I always click the sexy file in here. I'm not sure why, but I do it. And you can see here in the top, my favorite editor doesn't really like this file because it's so super large. And yeah, I don't blame it. It's for smaller files usually. But you can see we have some data description, even though this file doesn't have so much in it. And here at the bottom, I skipped the data in here because I don't plot data just by looking at it. And here we can see the process data aggregate document contains the peak list, which, yeah, we are the major thing we are after, basically. So what if there was an editor that could display ASM just a bit nicer? And I know from the European meeting, there was quite the demand for it. So we did it. We actually created one, and it's, I have to navigate, OpenChrom Connect, and it's data and it's export, and, or maybe I can choose a simpler model. This is an official ASM standard, and we can see we plot the data. We show actually the data description, in this case as a tree, because yeah, that kind of seems to be the natural thing for JSON. I'm not showing you the data points because we are plotting this above, so I think this should suffice. And I know some people like these graphs, me included, so let's make this. What I just did is I made the canvas a bit larger, so we have less overlapping, but you can also move these around by hand if you want to make nice screenshots for your boss or something. So, and this has the same features. It has search, we can zoom out, and we can see the peak list in here, and we get the structure of the Allotrope simple model. And I mean, it's not so super simple, but it is definitely digestible. I'm also a huge fan, so we have whenever we have ADF implemented now, we have always a matching ASM if there's a model for it. And yeah, then the question is, did I say this is a chromatography software? Well, I wasn't properly looking straight because, of course, there's so much more. Maybe you also saw it when I saw showed the plugins. There were some Thermo Fisher FTIR instruments in there. So there's also basic support for it, like we can look at the absorption spectrum, the transmission spectrum, and because the Allotrope data format is pretty cool, we can also look at the raw data. I think very few data standards are that great in this regard. So again, behaves just like a vendor format in here. So it's super great. So okay, already have spectroscopy somewhat included in here. Maybe we had GCMS I showed you, but what if we get rid of the GC and only do the MS? I'm a huge fan of Mailänder because I worked a lot with it. So we also have support for that. We can also open that up, export that. What do you want, ADF or ASM? Let's do ADF. So we do protein modifications, save it, and we have basically exported that as well. And there's actually also even a known perspective for Mailänder because it is somewhat special. You can see the peaks in here. And if you say, nice peaks there, but why are they not labeled? And I can assure you, we're working on that. Ben is smiling. Yeah, we will get it by Christmas. It's in the next quarterly release, and it's added to the milestone. So we will have proper labels in here, so Mailänder users rejoice. And yeah. What else did I forgot? Yeah, something that I'm not so super acquainted with, NMR, but I know it's an important technique. I mean, it can do things that nothing else can do. And I mean, we can look at the raw data. We can also process raw data up to this view where we actually see the singulates and triplets that you all know better than me. So we can also save that again as ADF, so we can use us as a converter. So we have that in our NMR perspective. And did I say NMR? So I also say PCR. This is maybe a bit strange. Why do we have PCR in the chromatography software? Well, before I joined Lablicate, I was a customer. And I basically told him, well, doesn't this look like curves, fluorescence data that you already have? And this is a file from Roche Light Cycler, which is popular in the lab that I worked. They never break, really robust, super nice instruments. And then we say, oh, wait a moment. Why is that? This looks like an amplification positive sample. What's that? Okay, it's the positive control. It's the German thing for positive control. I'm super glad. I thought we had norovirus in here, but I guess the seafood and the berries are all safe. So it's just this run is validated properly. The controls are set. So have fun at the reception dinner. That's my takeaway there. So we got that. And I think we still got some time, so let's also do something funny again. Let's go back to the data analyst view. Let's look at remember the perfumes that we did. We can now look at this, and we see you have some fragrances here, limonene, and also my favorite one. I really like vanilla, so maybe let's choose that one. Yeah, it's this one. And I know you all like AI and talking computers, so of course we have to have it. And what I'm doing now, I'm feeding into ChatGPT all the information that you see on the screen right now. That we think it's vanillin. I know we don't know for sure. It's just some certainty from a database search. We have the spectrum. And what I'm not really good at, I'm not a mass spectrometrist. I'm not really skilled in this case. I always wondered, I mean, these guys that look at this scan chart and they say, yeah, the 151 and 152 have this ratio. It could really be vanillin. So there's a lot of expert knowledge in there. Also something you can deduct from textbooks. And this is where ChatGPT excels. It knows the standard books of Fred McLafferty. They fed it in them, and it can also give some insights here. So this is just a fun experiment that we did when this generative AI was really peaking and everybody was thinking about how can we integrate this into our products. So my closing remark basically is, let's go back to the welcome screen. If you say, yeah, it's a nice fat client that you showed there. We migrated everything to web like 3 years ago. We have web developers in our company who can do this much better than me, and they already made some prototypes for ADF and ASM viewers, which also use ASM natively as a data source. It's really cool. We also have, if you say, yeah, if you say, yeah, sorry, microphone. We have a lot of glue code, like we want to do Python scripting, and it might be legacy stuff, but we use it, and I say I don't blame you. I also created many of those scripts myself, so we have also a command line version, a prototype. So you just, what I showed you, the batch process, you just feed in the data, you get in the result, and you do something like that. If you say, our programmers want the REST API, we also have a prototype for that. So we abstracted the user interface that you can see here from the algorithms, so we can produce those kind of things ourselves. So whatever it is, please contact us, click this button. This message goes directly to the CEO. I can approve that. And yeah, please contact us with any further questions. So thank you all for watching, and remember to like and subscribe.